We have Andrew Tunstall from WorkSafe Tasmania. Andrew is the Principal Mining Inspector with WorkSafe Tasmania. He will provide an overview of the current activities, trends and issues being experienced by the Mines Inspectorate at Tasmanian Mines and Quarries, and provide some practical tips for reducing risk. Thank you.
Thanks, Pam. Thanks, Pam. And yeah, like Jimmy, I'm one of these dual nationals that's been causing so much trouble recently. So you can probably hear from my accent. I'm just going to give you a brief presentation on a couple of the issues that we're currently engaged in with the Tasmanian Mines Inspectorate. And one of our primary concerns, I suppose, at the moment, following some recent events, has been the management of principal mining hazards. So I just want to talk a little bit about that, what they are, how they can be managed, and areas where we think improvements can be made. Then I'll talk a little bit about the Quarry improvement project that Willard's been heavily involved in, along with Yvonne. And then finally, just touch on a couple of other areas for improvement, which we think we're going to be focusing on next year, and we'd like the industry to have a think about too. I'm getting on a bit these days, so I've had to make myself some notes. Okay. So I guess most of you probably know who the Mines Inspectorate is, so I won't dwell too long on this, but we're essentially a department of WorkSafe Tasmania. There are 6 of us in the state, including the Chief Inspector of Mines, who's based at Rosny Park. We have 2 mines inspectors based at Rosny Park and 3 of us based in Burnie. So broadly speaking, the Burnie office covers the west coast, the north and the northwest of the state, and the Rosny Park inspectors cover the south. There is some overlap at times for investigations and audits, but generally that's how we run things. Okay. So the work of the Mining Inspectorate it's largely centred around assessing how sites are managing their principal mining hazards. And I'll ask the question, because I know Henty's been involved in a review recently, but what is the definition of a principal mining hazard? Yes, please.
So the way we're counting principal mining hazard is split. It's either single fatalities multiple times over or multiple fatalities once.
Yeah, exactly right. So the problem we have in mining is because of the high energy sources we use to crush rock and transport rock in the quantities we do, a lot of the hazards that we deal with fall under that definition of a principal mining hazard. So they have to be managed through a higher level of risk management than just a risk assessment. They have to be managed through what we call principal hazard management plans. The other point I wanted to make is a lot of these principal mining hazards are actually dynamic in nature. So they might vary through the shift, or they might vary through a typical working week. So for example, if we think about something like the risk of inrush, obviously when the workings are a long way away from the body of water, the risk is actually quite low. But as the workings approach the body of water, particularly if they intersect a geological structure which can connect the two, then that risk can suddenly increase. And that's in contrast to a lot of industries where you're essentially dealing with hazards that you fully understand and which are reasonably static in nature. The other thing is it's generally agreed that the usual lag indicators that we use to track a company's safety performance, like lost time injury rate and total injury frequency rate, are not necessarily good indicators of the fatal risk profile of a mining operation, because the hazards that cause lost time injuries are often very different from principal mining hazards. So back and neck injuries and mental stress, the hazards that cause those are obviously different from the hazards that might cause an underground fire or explosion. So I'll talk you through an example now which illustrates that, along with some other points. So what happened here was a jumbo had broken down in a heading. If I can get this thing working. Oh, okay. Well, a jumbo had broken down here in a working. He was doing some stripping for a cutting in here. And two fitters arrived to start working on the jumbo. And as they started fixing the jumbo, one of the fitters noticed some small rocks falling out of the backs and hitting the roof of the canter. So he was a fairly experienced fitter, and he recognised that that was probably the sign of an impending rockfall. So he withdrew from the area with his offsider. They went around to the back of the LV, and they were standing there when the jumbo operator and his offsider arrived from crib. So the four of them were standing behind that LV, just having a chat about what had happened, when there was a sudden rockfall of about 200 tons, which fell basically without warning. So that was the rockfall. You can see it's buried the canter, it buried the LV, and it buried part of the jumbo. So it was very lucky that they withdrew when they did, because if the rockfall had happened 5 or 10 minutes earlier, or if it had happened, or rather if the fitter hadn't noticed the signs and withdrawn, that incident would certainly have led to 1 or 2 fatalities. There are some fairly interesting points that come out of that incident, which I'll just share with you now. The first thing is that there was nothing in that site's lost time injury frequency record that suggested that a catastrophic accident was about to occur. The LTIFR was quite low, and the trend was quite flat, so there were no indications that anything was wrong. The second point is that, as I said earlier, the reason a fatality was averted was because the fitter recognised the signs that things weren't quite right and withdrew from the area. And this is a really important point when you're developing principal hazard management plans, to realise that it's that last minute intervention by the person at the coalface, if you like, that is often the difference between a fatal accident and a near miss like this one. And those are obviously integrated into what we call the TARPs, the Trigger Action Response Plans, which give clear instructions to the operators as to what they have to do if they notice unusual conditions developing. The third point I just wanted to share was that after this rockfall occurred, a much more conservative ground support regime was installed in areas which were being mined adjacent to the geological structure along which the failure occurred. So it was essentially sort of hard to show you here, but it was a steeply dipping fault structure which came in something like this along the sidewall. Now that was put in recognition of the fact that it hadn't been possible to predict the rockfall before it occurred, because although kinematic analysis was done on the area, there was no horizontal joint set as such, which would have allowed the model to predict that the block was going to fail. The failure plane along which it occurred was essentially a series of very small minor joints which linked up because the weight of the block was essentially pulling down and allowed the failure to occur. And since the increased ground support was put in, they've had no further incidents of that nature at the site. And again, that just illustrates the importance of thoroughly investigating these high potential incidents and doing what you can to make sure that risk controls are increased. Excuse me. Okay, I'll just briefly, conscious of the time, I'll just briefly touch on principal hazard management plans. So principal hazard management plans were originally introduced following a couple of disasters. One was the Mara disaster, where a large explosion killed a number of workers. The second one was the Gretley inrush, which occurred in a coal mine which accidentally mined into flooded workings. And the coroners that were investigating those accidents recommended the development of principal hazard management plans because the legislation that existed at the time was fairly prescriptive, and it just didn't allow that risk-based assessment of the hazards and the risks on the site. Originally, they were designed for natural hazards like inrush and gas, but the definition, as we've heard, has been expanded to include any hazard which can result in multiple fatalities in one incident or single fatalities in a number of incidents. So in a typical underground mine, that will cover perhaps 10 or 15 principal hazards. I'll now move on to the Quarry Improvement Project, which we've been running for a couple of years now and which has achieved some very good results, as well as allowing us to get lost on numerous occasions trying to find small quarries and interact with some fairly interesting characters. So for a number of years, the level of resourcing in the Mines Inspectorate, along with the number of notifiable incidents that we were investigating, didn't really allow us to do much proactive work at the quarries. We investigated some accidents, but we didn't really put in place a proactive program. However, in 2015, a combination, I suppose, of a reduction in notifiable incidents from underground mines, along with recommendations from Professor Michael Quinlan, who was carrying out an audit of the Mines Inspectorate, that we actually start proactively visiting quarries, led us to develop a proactive quarry improvement program. Yeah, I'll just mention that after we visited a couple of quarries unannounced and started looking around at some of the hazards and risks, we realised that at most quarries there was too much work to be carried out. For example, with one improvement notice, there was a lot of work, and so we decided to adopt a staged approach where we essentially started with what we considered to be the highest risks and then gradually worked our way through the lower risks with the operators over a period of probably 3 visits, which was about 18 months. Yeah, we found that it was a 2-tier industry. The quarries that were owned by the large national companies like Boral were actually very good. They had quite sophisticated safety management systems in place. They had toolbox talks, they had a good safety culture, and their machine was well guarded. Whereas some of the smaller operators, particularly the one-man operators, left a fair bit to be desired and caused us to raise our eyebrows initially. So one of the challenges we did encounter in the quarries was that many of the smaller operators just weren't familiar with modern risk management techniques, but they were quite willing to carry out improvements if we gave them clear directions. They were struggling with things like risk assessments and risk management, but if we said to them, look, you've got to guard that machine, they would guard it, there was no problem. So we weren't quite sure how to address that because the legislation is obviously risk-based legislation. So in the end, we developed a quarry checklist, which was basically taken from the health and safety legislation, but it gave operators a clear set of instructions as to what we expected to see when we visited their quarries. We provided that to the quarry operators, and we told them that when we visited the quarries, this is what we're going to be looking at. So you've now got an opportunity to get it fixed up before our next visit. I think, Willard, it's probably fair to say some have taken up the offer and others haven't. Yeah, so the Quarry project, it's been very interesting, and it's given us some fairly amusing moments. One visit that Willard and I were involved in, we decided to take a UHF radio along in case we had to communicate with trucks on the haul road. And as we turned up at this quarry, we saw a bunch of blokes in the distance, no PPE on. And we could hear them on the radio discussing who we might be. Finally realised it was a government vehicle, and there was a flurry of reflective vests and safety glasses. By the time we got there, they were all perfectly dressed. So yeah, there is still some work to do in the quarries at reducing risks, and our current focus is on reviewing the systems that are in place for controlling airborne dust, which I'll touch on a bit later on. However, constructive working relationships have been developed, not just with the quarry operators, but also with the IQA. John's been a fantastic champion of the project, and the CCAA, and I've got no doubt that as time goes on, we'll see further improvements. I'll just move on now to a couple of areas where we believe OH&S improvements can be made in the industry. But I think I've missed a slide, so I'll just go back. Yeah, I'll just briefly take you through some of the things we saw at the quarries. So as I say, the larger quarries were actually quite good. They had good safety management systems in place. This was fairly typical, where a drum was guarded at one stage, but a fitter had cut a hole in the guard so that he could grease the bearings. And really that was just a question of us explaining that they can extend the greasing point outside the guard and get the guard repaired. And this one here was an ammonium nitrate storage container, which was probably 50 metres from the main office of the quarry. And over time, flammable materials had been allowed to accumulate. So we had pallets. There was a big row of gum trees at the back here, a couple of oil drums. And quite interesting, when we spoke to the quarry operator, he really couldn't see the risk. And when we explained to him that, you know, if a decent bushfire got going and the ammonium nitrate storage container was heated, it could explode and basically take out the entire office. Then he very quickly removed the vegetation and just really through basic housekeeping significantly decreased the risk.
Andrew, how many quarries, I know it's quite substantial, how many quarries is sort of responsible for?
It's a good question, Dennis. We've probably got about 50 level 2 quarries, which are the sort of medium to large ones. And we really don't know. We suspect there are probably hundreds of small ones dotted around. Yeah, it could well be. Yeah, 360, is it?
Official one, 367.
Yes.
Then you have the backyard gravel pits, and you have thousands. Big job.
Yeah. It is, and realistically, we can only get to the larger sites with a higher risk, so we tend not to visit the very small quarries unless there's an issue. So the 3 critical areas for improvement, I think, that we'll be focusing on next year. The first one is the management of critical controls. The second one is occupational health and hygiene. And the third one is the development of health and safety reps. And I'll just briefly touch on those before lunch. So many of the incidents we investigate involve critical controls which are either absent or have failed. By critical controls, we mean controls which, if you remove them, it significantly increases the chance of an unwanted event happening, or perhaps controls that span across several hazards. So an example is refuge chambers in underground mines. Obviously, if there's an underground fire or an explosion that develops an irrespirable atmosphere, we need a place where miners can go, which can sustain life for the period of time it takes to extinguish the fire or to rescue them. So most mines would have, I'm not sure how many you guys have at Rosebery, perhaps more than 20. Yep. Most mines would have lots of these refuge chambers scattered around at intervals of about 700, 750 metres underground. Excuse me. So although these are critical controls, when we do our inspections, we often find problems with refuge chambers. We find inadequate drinking water, we find batteries have failed, we find communications not working, sometimes we find structural damage where they've moved the chambers. Now these are critical pieces of equipment. They need to be operational 24/7, 365 days of the year, because an underground fire can happen at any time. And the last thing you want is for operators to turn up at a refuge chamber and find it's not working as it should. So we asked the question, why is it that for such critical controls as refuge chambers, mines inspectors are finding issues and the internal inspection regimes at the mines aren't picking them up? We think it's because there's no real quality assurance process in place to check that the inspections that are supposed to be being done on refuge chambers are actually being done to the standard that is required. We can think of numerous examples of why that may not be the case. The inspector is sick, not the mines inspector, the internal inspector is sick. There's been a change of rosters, or perhaps the checklist is inadequate that he's using for inspections. But the reality is that critical controls like refuge chambers should be 100% all the time. The other thing we sometimes find is that because there are no performance standards written for refuge chambers at some operations, refuge chambers may have defects detected by the inspector, but while those defects are being corrected, they're still left in use. So although they're not 100% effective at that time, they're still being used as refuge chambers. And that probably reflects a lack of written performance standards that says, for example, if 2 batteries have failed, the refuge chamber has to be withdrawn from service, and all people have to be withdrawn from that area that's being serviced by the refuge chamber. Okay, so I guess a lot of you would be familiar with this. This is a critical control management document, which is called Health and Safety Critical Control Management Good Practice Guide, produced by the ICMM. It provides a very, very good description of how critical control should be managed. It includes performance standards, it includes accountability, and it also includes reporting up the chain of command to the site senior officers. So the site senior officers should know that at all times their refuge chambers are operating at 100%. And we spoke a bit earlier about the fact that LTIFR is not a great indicator of the fatal risk at a mine. The document also contains some suggestions as to how the performance of the critical controls could be used to track the way critical controls are being managed over time. So in this case, you can see that this critical control has been effective during, say, 75% of the time here, and that's gradually increased to close to 100% of the time, which indicates that the management of that critical control is improving. It's difficult to come up with lag indicators for some of the principal mining hazards, but you might use something like the number of high potential incidents that are related to that risk. And if you see that one going down and the critical control performance going up, then it gives you some indication that your critical control management is improving. Oh. Okay. Right. So the second area for improvement is occupational health, which has been brought into focus really over the past few years by 3 events. The first one of those was the International Agency for Research into Cancer announcing that diesel particulates cause cancer in humans. That was in 2012. Obviously, it had been suspected before then, but not proven. The second thing was the emergence of the black lung disease in Queensland last year. Black lung was a coal mining disease which was thought to have been eradicated, but re-emerged. And the third thing is the concerns expressed by the Thoracic Society of Australia and New Zealand that silicosis is actually re-emerging in Australia, particularly for people working with manufactured concrete kitchen bench tops, which contain high degrees of silica, obviously not wearing proper respiratory protection and not suppressing the dust. So it's a concern because all those diseases are wholly preventable, but it does require, I think, an increased focus from the underground mines, particularly in things like diesel particulate filters, closed cabs, dust suppression, dust monitoring, respiratory protection, and so on. We don't want a similar thing to develop in Tasmania. And finally, I'm aware lunch is on the way, but I'll finish off quickly. The third area for improvement is the development and mentoring of health and safety reps. Some companies do this really well. So they give their health and safety reps the basic training, the 1-week course, and then they regularly engage with them. They use them for investigations, they use them for audits, they interact with mines inspectors when we come to site. And those health and safety reps develop really constructive relationships with mine management, and they provide a very useful conduit for transmitting information up and down the chain. Other sites elect health and safety reps. They put them through the basic training course, but then they put them back on a truck or a bogger, and because there's often no coverage for those reps, they often don't see management until the next safety committee meeting, which depending on their shift roster could be 2 or 3 months down the track. So those guys don't really develop the confidence to constructively engage with management, and they're certainly not being used to their full potential as intended by the legislation. So I don't think there's a simple solution, but we want to work with the industry next year and take some examples of sites that do engage with their health and safety reps and try and get some of that knowledge to the sites that don't. So, yep, that's about it really. I'll close now because lunch is on the way, but thanks very much for listening, and I'm happy to take any questions either now or during lunch.
Certainly the pressures that I saw in the mining industry through tough times when mining companies had overspent or spent unwisely made them turn a blind eye to low probability, high consequence events in terms of pushing through those sorts of barriers in Tasmania. How have you tried to engage that level of complacency from time to time?
Yeah, it's a good question. I suppose the development of the principal hazard management plans, which only took place a few years ago, has focused mine management on those potentially catastrophic events. They've had to consider them as part of the development of the principal hazard management plan. And I think that has partly brought them into focus. But I still think there's a tendency in underground mines, because you're dealing with so many hazards, to treat some of those risks in a similar way as you treat some of the perhaps the less catastrophic risks. Yep. Any other questions? Okay, thanks very much.